Lopatina from Unstructured.
And I'll go over to share my notebook screen now. So I'm just going to unstructured.io to find the notebook, going to our documentation and example code. And here's our Llama 3.1 evaluation on unstructured text. So I'm going to just start by just doing the pip installs while I go through some of what I've written up here, because those might take a little bit. So first we'll be transforming the PDF, and then we'll be creating a synthetic data set. So getting started here, we have pip installs for the unstructured and LangChain and transformers libraries in Ragus. And then we're using the unstructured API in this example. So there's all the pip installs. I'm using Google Drive to like save files and stuff and have my .env file in there. So I loaded my .env file. I'm saving some of the paths. So this notebook takes like an hour to run. So we're not going to be running all of the sections live, especially getting 82 answers generated. And so there's a lot of sections where I'm saving the progress so far so that you can just pick it up later, because sometimes these notebooks time out. So here I'm starting the unstructured client, and then this is the path to the PDF that I wanted to process. So here we're downloading it, and then we're partitioning the file. We're chunking it by title. I chose 512 character chunks. I didn't really optimize this part of the process because I really wanted to try this out to see how the evaluation framework works and things like that. And then we're taking the text out. And so we're doing this just on a small scale, especially because we don't want to like take a whole set of documents and embed them. For this, we're just trying something small because this notebook takes about an hour to run through. So I ran it once to get the Llama 3 results, and then I had to run it again for another hour. But with Unstructured, you can swap out this processing for the ingestion setup in our documentation, and then you could just link it to a whole directory and then grab and also embed it and just grab that if you want to do this at scale. So here we're using LangChain to get the documents formatted in the way that Ragus wants to see them. And here we are setting up the test set generation. So I chose GPT-4 as actually I wouldn't recommend 3.5 anymore. We're using that as the generator and also the critic element. And we're also generating the embeddings for these questions and answers. And we are also setting the question type distribution. So I just picked an even split of simple, multi-context, and reasoning questions. And then this is where you would run the test set creation, but I have already run through it and saved it. So it's just loading that just to not have duplicate API calls. And then I had to do a little bit of cleanup of those because you would get like not a number or like the string version of it, or I didn't want to evaluate ground truth where the answer to a given question is not present in context. So I had generated 100 questions and ground truths, and then I ended up with 82. So that's why my test set was 82 and not 100. So I guess if you wanted a larger test set, I would aim for more because you'll end up filtering. This was just something I ran to just like take a look at a few of the questions. And I will say I first made this notebook when Llama 3 came out last May. And so I did look at one question. I kind of looked at some of the questions for a sanity check. And I think that the questions in ground truth have improved since then. I'll get to that toward the end of the notebook, possibly from an improvement in GPT-4 or from an improvement in the Ragus framework. But, synthetic test questions, you always kind of want to sanity check them. And when I looked at them, some of them were pretty good. And then, for example, there was a question on which model helped assess GPT-4's RAG, and it was not GPT 3.5. GPT-4 was actually the one assessing in this paper. So that being said, I would say it's helpful to actually look at the questions and answers to get a sense of how you want to interpret the results. And then, so here I have to use lu.ma 3 or 3.1, you have to go to the models page. So here, I'll just do the notebook login here. And before that, I had set up access to the weights of the model. So that is a little bit of a lead time item. If you want to do this, you want to go set that up. It usually takes about 10 to 15 minutes to get the approval. And so we then quantized the model. And first we set up the retriever, and we're just doing a local, I also don't know why. The recommended way to do the Hugging Face token in a notebook is the one I put here, but then it'll also ask for the one in my Google Drive secrets. So that's a little bit of a bug in the notebook, I guess. And so here I'm setting up a local face, that's how you pronounce it, vector database. And then here is where we will be tokenizing the model so that we can run everything on this free Google Colab notebook. And then after these steps is where we would be setting up the the RAG chain. So this is the prompt format that my colleague Maria recommended for getting the best results. And so we're going to be doing all the imports and setting up the format docs function. And here we're setting up the RAG chain. And so, we defined the model, I think, higher up somewhere. And for the prompt, it's just a very simple prompt. I guess, if you were going to try this out on a different paper, you would want to tweak the question a little bit. Just a few things like saying, I don't know, if you don't know the answer, not making up to discourage hallucination. And and here the RAG chain is getting set up. So this is kind of a quick and simple example, but if you wanted to improve your model's performance, you could try this flow with the evaluation and try tweaking the prompt and seeing if a more elaborate prompt might help you get better responses by comparing the results. And similarly, the chunking strategy I used was not optimized. So this is a great setup to kind of start with and then tweak parameters to see if you can change your performance.